Today we're going to talk about solving rational equations. So rational equations are equations where we happen to have the variable or a variable expression in a denominator in that equation. So for example, this is a rational equation because we have fractions, rational expressions. We have variables in the denominator in this expression. So this is a rational expression. This has fractions in it, but it's not a rational expression. And the reason why is because the variable is not in the denominator anywhere. All right, this is just a regular old equation with fractions in it. You know, subtract 1/2 from both sides, deal with adding and subtracting fractions. This is a little bit different. And we do have a strategy that we can use for solving rational expressions. But I need to tell you that one of the things that can potentially occur when you're solving a rational equation is that you can get extraneous solutions. So as we've gone through various techniques this year, we've come across other processes that have created extraneous solutions. This is one of them. So we have to do a check for that when we are solving a rational equation. Now, the strategy for solving a rational equation is actually right up here, and that is to multiply each side by the least common denominator. All right, so the first thing we're going to do, if we go down here to the example 1a, is we need to factor our denominators so we can determine what the lowest common denominator is. Would you agree this is going to be x plus 3, x minus 3? Fair enough? And so here's what this means. If we look at identifying our LCD, it would be x plus 3, x minus 3. And we need to think about what our excluded values are. And if you recall correctly from other processes we've done, anything that makes the denominator 0 can not be a value for x. So out of this, x cannot equal either plus or minus 3. All right? So the next thing we're going to do is multiply both sides of the equation by that lowest common denominator. So over here, x plus 3, x minus 3. And over here, we've got to multiply by x plus 3, x minus 3. And when we do this, it looks like we have a whole lot of stuff. And keep in mind, this is in the numerator. There's a 1 under it if you want to think of it as a fraction. So this whole thing goes to the numerator. So when we distribute this whole thing to here, would you agree the x minus 3's cancel out, right? Yes. Okay. So what you're left with is going to be x plus 3. Now, you have to still distribute the entire thing over to here. And would you agree, when you distribute this whole thing over to here, the x plus 3's cancel out, right? And so you're going to have x and x minus 3, right? And if you go over here, both the x plus 3 and the x minus 3 are going to cancel out. So all you have left over here is a 2. That's it. Next thing we want to do, distribute. So this is x squared plus 3x plus x squared minus 3x equals 2. And I can see I'm going to need to get everything onto one side here because I'm going to have some x squareds. I'm going to have 2x squareds. None of these. Oh, let's just leave this like this. Equals 2. Fair enough? Because here's why. Let's divide both sides by 2. And that gives us x squared equals 1. Fair enough? And we take the square root of that, and we get x equals plus or minus 1. Would you agree to that? Okay. Now, what we have to check for is that the answers we got aren't one of our excluded values, and they aren't. So these are going to be good answers. If we got an answer that was the same as one of these, it would be extraneous. It can't be a solution because we've already said x can't be these things. So let's go down here to the next example. And we need to factor this, and this is x plus 2, x plus 1. And so our LCD would be x plus 2, x plus 1. And would you agree x cannot equal negative 2 or negative 1? Okay, so we need to multiply both sides by x plus 2, x plus 1. And over here, we got to do some distributing. Now, would you agree, when I distribute this whole expression to my first fraction, these are both going to cancel with the bottom, aren't they? Okay, so all I have left is x minus 1. And when I distribute both of these over here to this fraction, the x plus 2's are going to cancel, aren't they? And so I'm going to have plus 2x times x plus 1. And then over here, the x plus 1's will cancel. And I actually am going to have to FOIL what's left of this, right? This is going to be x minus 1, x plus 2. All right, and that'll be my next step there. So let's go ahead and distribute and FOIL. So I've got x minus 1 plus 2x squared plus 2x equals x squared. I think we got plus x and minus 2. Do we agree on that? Okay. So we're going to have x squared. So if you recall from solving quadratic equations, you need to get everything on one side here. So subtract that x squared on both sides. Subtract that x. Just take it away from there. Add that 2. And let's see what I've got. 2x squared minus an x squared gives me an x squared. Then I've got 2x. And then I've got plus 1 right here. Negative 1 plus 2 gives me plus 1 equals 0. Fair enough? Okay. And I need to factor that at this point. Remember solving quadratic equations? So this is going to be x plus 1, x plus 1. And this is going to give me x equals negative 1, right? Okay. Back the truck up. There's a little problem with that.
Extraneous.
It's extraneous. We can't have x equals negative 1. So actually, you pull an arrow there. Let's write here. This is extraneous. This equation actually has no solution. Okay? No solution. Because our only solution was an extraneous solution. Okay. Got a couple more we could do. C is super easy. Would you agree our LCD is just x plus 2 and x cannot equal negative 2? Okay, and all we have to do is multiply both sides by x plus 2. And they'll cancel with the denominator on both sides, and we will have x minus 1 equals x squared plus 2x minus 3. And we're going to need to get everything on one side. So I'm going to subtract an x. And I'm going to add a 1. And let's see what we've got here. We've got 0 equals x squared plus x minus 2. And I need to go ahead and factor that. So how about x plus 2, x minus 1? All right, and would you agree that's going to give me x equals negative 2 and x equals 1, right? However, what's the problem?
There's
Yeah, this is not a solution. This guy right here is extraneous. So this is your only solution. That's your only solution. All right, last one to do. What would our LCD be?
X plus 1, X plus 4.
Yeah, x plus 1, x plus 4, and what are our excluded values?
Negative 1,
-1,
negative 4.
-4. And on both sides of this, we're going to have to multiply by x plus 1, x plus 4. Okay, would you agree? When I distribute this over to here, the x plus 1's cancel, right? So all I have left is the x and the x plus 4. And when I distribute this over to here, the x plus 4's cancel, and all I have left is my 3 with the x plus 1. On this side, the x plus 4's cancel and leaves me with something I'm going to need to FOIL. So x plus 3, x plus 1. So let's distribute and FOIL and see where we go from here. So this is x squared plus 4x plus 3x plus 3 equals x squared plus 4x plus 3. Do we all agree? Have I made an error in there anywhere? Okay. I love this. This is going to be nice because you agree we can subtract those x squareds right away, right? And I have 7x plus 3 equals 4x plus 3. Subtract 3 on both sides. This will get you going crazy. 7x equals 4x, and this is usually where people get stumped, which is why I take you down this lovely road. What do you think we do at this point? Subtract the 4x on both sides. This will give you 3x equals 0, and what is your solution?
0.
Exactly, x equals 0. And it's not an excluded value. All right?